So until now, we have two equations that states that A into B, A dot B is equals to A1 B1 plus A2 B2 plus A3 B3. And we also know A dot B is equals to modulus of A into modulus of B cos theta. So by using these two equations, I can come up these two equations. I can come up with an equation for and. So cos theta is equals to A1 B1 plus A2 B2 plus A3 B3 over modulus of A into modulus of B. What's happening here? I'm equating these two. So this will be equals to this A1 B1 plus A2 B2 plus A3 B3 is equals to modulus of A, modulus of B cos theta. And I am bringing these two terms to the denominator so that I can have this. And when we are applying these two equations, we should be certain that vector A and vector B are not null vectors. They cannot be null vectors or zero vectors. Their magnitude should be always greater than 0. Keep that in mind. Let's say there is a question such that x is equals to 1, 2, 3 and y is equals to 4, 5, 6. Let's say the question asks us to find the angle between these two vectors. Let's say that is the question. Well, let's find out. What's the angle? What's the equation for the angle? Cos theta is equals to A1 B1 plus A2 B2 plus A3 B3 over modulus of A into modulus of B. In this case, we have x1, x2, x3 and y1, y2, y3. So that is equals to 1 into 4, 4 plus 2 into 5, 10 plus 3 into 6, 18 over, we have to find the modulus of x first. So modulus of x will be equals to square root of 1 square plus 2 square plus 3 square. And that is equals to square root of 149. So that is how much? 145, 5 plus 9, 14. And similarly, modulus of y is equals to square root of 4 square plus 5 square plus 6 square. So that is equals to 16 plus 25, 41, 41 plus 36, 77. So we have square root of 14 into square root of 77. That is equals to 1432 over root 7 will give me 7 and I will be left with 2 and 11, so square root of 22. And the final answer will be 32 square root of 22 over 7 into 22. I can cut this and I will get how much? 16 square root of 22 over 77. And you can use the calculator to find the theta, which will be equals to cos inverse 16 square root of 22 over 77. But my idea here is, what do you think of the angle theta? Is it acute angle or is it obtuse angle? Well, we can say since cos theta is greater than 0, we can say theta must lie in the range between 0 and pi by 2. Why is that? Well, according to the quadrants, the angle, the ratio cos theta is positive in the first quadrant. It is a positive value. And in the second quadrant, the value is negative. Here, the cos theta is a negative value, has negative value. Since this is a positive value, since cos theta has a positive value here, I can definitely say theta is an acute angle. And if it was a negative value, I will definitely say the angle between vectors x and y is an obtuse angle. So I can visualize this. If x is somewhere like this and y looks something like this, well, this angle theta is an acute angle. This is the question 1. Now, let's say there are two vectors such that x is equals to minus 4i plus 7j plus 13k. And let's say there is a vector y which states it is equals to 1i plus 2j plus 3k. And if they ask us to find the angle between these two vectors, well, you can rewrite this in the matrix format, or you can just directly multiply. Okay, x dot y. Okay, sorry, cos theta will be equals to minus 4 into 1, which will give me minus 4, plus 7 into plus 2, which will give me 14. And I'm going to make this a negative one, or else it's not challenging enough. So 13 into minus 3, which is equals to minus 39 over, okay. And now we have to find the square root of, the modulus of x. And we know modulus of x will be equals to square root of 16 plus 49 plus 169. 16 plus 49 plus 169. And modulus of y will be equals to square root of 1 plus 4 plus 9, which is equals to 14. So I can multiply these two, 234 into square root of 14. This will give me minus 29 over square root of, well, I can take 2 out from both. So this will be square root of 7. This will be square root of 117. And I'll get 2. So this will be equals to minus 29 over 2 into square root of 819. Okay, so this is the cos theta angle. The main idea I wanted to showcase here is that the angle can be, the ratio cos theta can be in a negative number, can be a negative number. Then we can say theta is in the second quadrant, which means it's an obtuse angle. This is an obtuse angle. Okay, this is what I wanted to show you in this specific question. Now, let's say there is a question that states, show that vector x and vector y are not perpendicular. So how can we do that? Well, first of all, we have to know the vectors. So vector x is equals to, let's say they have given us 1, a, 4, and let's say vector y is equal to 3, k minus 1, and 2. So if vector x and vector y are perpendicular, we know the dot product of x and y should be equals to 0. Because if they are perpendicular, theta is equals to pi by 2, and x dot y is equals to modulus of x into modulus of y cos theta. And since cos pi by 2 is equals to 0, it should be equals to 0. So we can apply this. Actually, we can apply this to our benefit. How are we going to apply this? Well, first of all, we'll find the dot product. X dot y is equals to 1 into 3 plus k into k minus 1 plus 4 into 2, which is equals to 8. So this will give me k squared minus k and plus 11. So if these two vectors are perpendicular, this must be equals to 0. If we can find real values for k, which satisfies this equation, quadratic equation, we can confidently say that these two vectors are perpendicular at these two values. Okay, if there are any number, okay, real value that satisfies for k and k minus 1, well, that means x and y are perpendicular. Well, let's check that. So here, according to this specific equation given, k will be equals to plus 1 plus so minus square root of 1 minus 4 into 1 into 11 over 2 into 1. So that will be equals to 1 plus or minus square root of minus 43 over 2. This implies k has no real values, which means since there are no real values, we can say x and y are not perpendicular to each other. X and y are not perpendicular to each other. But if we had something like, I don't know, -1, -3, and sorry, not -1, -3, -1, and if we had -2 here, okay, we would have had two instances where x and y are perpendicular to each other. Okay, so this is how you have to tackle this specific question. Let's say there is another question, okay, that states vector x is equals to 4k minus 7 and vector y is equals to 3kk. And they are asking us the values of k for which x and y are perpendicular. How can we do this? Well, since they are saying x and y are perpendicular, we can say x dot y is equals to 0. And we can apply this. How? X dot y will be equals to 4 into 3 plus k into k, which is k squared, plus minus 7 into k. So which means I can say minus 7k directly. Minus 7k. And this is equals to k squared minus 7k plus 12, which is equals to 0. And I can factorize this perfectly. So that will give me k minus 3 into k minus 4. So that is equals to 0. So for the values k is equals to 3 and k equals to 4, x and y, vector x and y are perpendicular to each other. This is another question that we can do in scalar product. Now let's look at another type of question. Okay, let's say they are asking us to find the value of 3i dot 4i minus 5j. Okay, so these are universally known unit vector signs. Okay, so we know modulus of I is equals to 1 and modulus of j is also equals to 1. And another specific thing that we should take care here is I into j is equals to 0. Why? I and j are perpendicular to each other. Okay, so they are not going to give all these data for you. They are not going to give you all these data for you. They will only give this specific question. And you should be able to remember these things and apply here. So this will be equals to 3i into 4i will give me 12i into I minus 3 into minus 5 will be 15i into j. Okay, so I into I, we know that is equals to I square minus 15i into j. Since we know I into j is equals to 0, I can safely say that is equals to 15 into 0. So this will be equals to 12 into 1 minus 0, which is equals to 12. So this is the value of the scalar product of these two vectors. All right. So these two vectors, this is the product. Thanks for watching the 9th video in our vector series. If you found these dot product practice questions helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors. Follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.